So my grant is specifically to monitor marine plastics in Canada's north. Plastics are in every ocean in the world. 92% of them, meaning almost all of them, are smaller than a grain of rice, 5 millimeters or smaller, which represents real problems for trying to track them. So we're building technologies, 3 different technologies. Biological monitoring, so looking at fish and birds as sort of things that eat plastic so you can track it. We're making trawls, surface trawls, things that go along the surface of the water, both for ordinary people to build and use, do-it-yourself technology, as well as high-tech trawls for industry. And then we're also trying to figure out how do you monitor shoreline plastic when there are rocks and ice, because there are no protocols for that. You actually can't do marine plastic science in the north because it's built for Bermuda. So we're developing these techniques so that we can eventually have a Canada-wide network, because if you can do it in the north, you can do it anywhere. So there are plastics in every ocean in the world. They tend to accumulate in giant, slow-moving currents in the middle of each ocean in the world. There are 5 oceans in the world, so there are 5 currents called gyres. They tend to accumulate in the middle because the water cools and sinks, and as it sinks, everything floating stays in that place. So the Great Pacific Garbage Patch, that's the most famous. We're looking at the North Atlantic gyre, but there are also plastics not in those accumulation zones, like in the Arctic. There are plastics. There are plastics in all oceans. There are plastics in the Great Lakes. There are plastics in headwaters. But these tiny plastics are of the most concern because, first of all, almost all plastics, 92%, are tiny. And it means that most of the trophic levels, most types of animals in the ocean eat them, including plankton. They get so small that they can circulate in the blood of mussels, tiny pieces of plastic. And plastics absorb chemicals. So if you've ever had curry or spaghetti in Tupperware and you can't scrub the orange color out, that's an example of how plastics accumulate and sort of hang on to oily chemicals. But in the stomach, which is hot and abrasive and acidic, those chemicals come out again. And they can accumulate in the animal and biomagnify up food chains. So polar bears and humans at the top of food chains are eating most of these plastics. So the point of this research is trying to just figure out what the problem is so that we can figure out how to address it. Cleaning up is generally thought to be not the solution, right? It's a stock and flow problem. It's kind of like trying to bail out your boat before you've plugged the hole. So we're trying to see what's in the boat so that we can figure out where the hole is and plug it. And it's mostly plastics coming from industry, from landfills into water, from land into the water. And it's not about cleaning things out of the water, because once you clean them out, you put them in the landfill where they then blow or erode back into the ocean again, right? So we're trying to figure out how to stem the flow of plastics, mostly packaging and disposables, into oceans, also from fishing gear, particularly in the north.